And I'm going to do two more examples on Mohr circle. And it's one of the not complicated, but it's one of those questions that's pretty abstract. Okay. I'd like to attempt those questions with you. And then after that, we are going to do deal with normal stresses induced by centric and eccentric bending. Okay. So if you go, I've posted the examples I'm going to do. If you can go onto Avenue to Learn, you should be able to see these images. Okay, so this is the first example. Okay, so this is example number 1. So two wooden members, 80 by 120 millimeters uniform rectangular cross section, are joined by the simple glued scarf spine shown. Okay, knowing that beta equal to 22 degrees, and at the maximum allowable stresses in the joint are respectively 400 kilopascal in tension and 600 kilopascal in shear, parallel to the splice. Determine the largest load P that can be applied. Okay, so you have a structure like this. So whatever they measured is at the angle beta over here, which can withstand a tension of 40 kilopascal and 60 kilopascal in shear. Okay, so now we're going to call this our X going up here. Let me draw. So this direction is our X, going up is our Y, this is Z. Okay, so for this case, the question where I take this out is analyzing using 2D Mohr circle. Okay, so this is a 2D Mohr circle example, but let's say we consider 3D, what will happen? All right, so we look at 2D Mohr circle analysis. So now what I'm going to do is I'm going to now at the beta point, I'm going to put an element. The element look like this. Okay, I'm going to put the element here. Okay, so when we do that, right, we're going to put an element over there. So when we do that, this is our X, this is our Y. Okay, so we know that over here, there's our element, right? And we are aware that over here we have a stress X, right? And we know that stress X is equal to P/8, right? So over here is when the element is at basically at 0 degrees, as you can see. So what we have is stress X is equal to positive P/8. And we are aware that stress Y is equal to 0 and shear XY is equal to shear YX, right? As you can see, there's an axial load P acting on it only. This is as good as equal to what? 0, right? So what we have on this element over here, this is the principal plane orientation. And why is at a principal plane orientation is very straightforward, because the shear stress is equal to 0. Okay, so there's a no-brainer that's given to us. Now, next, and then before we go any further, I'm going to call this X. I'm going to call this Y. And then we were told that at beta equal to 22 degrees. So now I'm going to sketch beta at 22 degrees. Okay, so I'm going to sketch, if I can, draw an element. So this is our element, and we're going to rotate it 22 degrees now, right? Now, when rotated 22 degrees, right, we can see that if we take reference with the diagram, basically it's rotated over here, right? It's going in a clockwise direction, 22 degrees, right? So from Y, from this is our Y, right? We are rotating this by 22 degrees, okay? So we are make aware that is in tension, right? At 22 degrees is at tension. So we are given that this is at tension, and this is at 400 times 10 to the power 3 Pascal. Now the shear, right? We don't know which direction. We don't know. Okay. So at this plane over here, I'm going to call this over here, this plane over here. This is my Y beta. Oh, sorry. Let me get rid of this. So that is our Y beta because we're going to rotate from Y. So I will call this one X beta. Okay, so we have Y beta, X beta. The only values we know is we know that normal stress Y beta. Okay, the only thing that we know now is stress Y beta is equal to 400 times 10 to the power 3 Pascal. And we also know our shear Y beta Y beta X beta is equal to shear X beta Y beta. And this is equal to 600 times 10 to the power 3 Pascal. However, we are not sure whether is it positive or negative. Okay, so we I better write down in words. Do not know if it is positive or negative shear. Okay, right? So with this information, right, we have to determine what is our load, P. Okay, we have to determine. So now we are going to sketch Mohr circle. We cannot draw Mohr circle now. We can only sketch. Why we can only sketch? Because we don't have absolute values. There's one point that we know. We know about Y beta. But we're not sure whether Y beta, the shear is in going towards the left, going up, or down, coming down towards the right. Okay, but we're going to sketch Mohr circle, and we can find out, and we can be very sure. Okay, so I'm going to sketch Mohr circle. Okay, so everything is in tension, right? So we're going to focus on tension. Okay, so we are going to so we know that this is our normal stress. And we know that this is our shear stress. Right? Element rotate clockwise, element rotate anti-clockwise. So we know that stress X is equal to P over A, right? And we know that this is our principal plane. So I'm going to sketch a point. Okay. I'm going to sketch a point over here. So over here, this is my stress X is equal to P over A, right? And we know that this is our stress Y line because the stresses are equal to 0. So from here, we know that this is our point X. And over here, this is our point Y. And we know the value over here, this is P over A, right? So from here, we can sketch a circle. Okay, 2, 4, 6, 8, 10, 11. So we can sketch a circle. And immediately sketching this circle, we can also identify our stress average. Okay, so stress average or center of circle, which is stress average, which is equal to stress X plus my stress Y divided by 2. So this is equal to P over A, and the whole thing divided by 2. This is equal to P over 2A, right? So now we can sketch our center of circle. Right? And at this point, this is our O. And then we are aware from here to here. Oops, I'll change color. From here to here. And then we know this value is equal to P over 2A. Right? Right. So now we also know from P to Y beta, right? I want you to focus on this diagram now. Right? From Y to Y beta is a rotation of clockwise 22 degrees. So now we are going to rotate from the center of circle 44. Okay, so I'm now going to sketch 44 if I can. Right. Okay. So over here, this is our Y beta. Okay. So from here, what can we conclude? Okay, we can conclude that the element will be rotating what? Clockwise. For the element rotating clockwise, we know that this shear stress, okay, the one over here, okay, this one is valid. Because the element is rotating clockwise. So when that's the case, this is how our shear stress look like. Okay. So the direction of shear stress, you have to depend on what? On Mohr circle, right? So now, given to us, right, that over here, the values, we have two values, right? We have a value of 400 of normal stress and a shear stress of plus 400, and we have a shear stress of 600, and both are in kilopascal. Okay, so this is the normal stress, and we are given shear stress. So now we have to find the normal stress value now. Okay, and also we have to find the shear stress value. So what we are aware of, this is this angle, right, is equal to 2 beta. Okay, because over here is beta, and then on Mohr circle is what? Is 2 beta. So now we are going to find the normal stress. Okay, so the normal stress right? So the normal stress, what we can do is the normal stress, right? So now just use Mohr circle now.